Anyway, I'd like to say thank you, Olivier-san, Setsu-san, and your colleagues to give me a nice opportunity, MITATE Lab seminar, to introduce our research activity today. My name is Seiji Hayashi from National Institute for Environmental Studies. Today, I'm going to present our ongoing research project, Reduction of Feeding Risk, Edible Wild Plants and Mushrooms in Fukushima affected area. This photo showed an area called Satayama in Japan. It is a border zone between mountain foothills and arable flatland. There are many Satayama regions in Japan, including Fukushima Prefecture. People in Satayama enjoy picking and eating edible wild plants and mushrooms. This is not only a food supply, but also part of an important traditional food culture. Edible wild plants are called sansai in Japanese, so I will use sansai as I talk about wild plants throughout this presentation. These pictures are examples of sansai mushroom and dishes made from them. Unfortunately, the Fukushima Daiichi power plant accident in 2011 deposited radionuclides in forests, causing contamination of sansai and mushrooms. Most people in evacuation areas still avoid eating them even now. To preserve the traditional food culture and enjoyment of sansai, information to reduce their anxiety about eating sansai is needed. These graphs show the concentration of radioactivity in 6 kinds of sansai collected by local residents in Mitate village. Overall, radioactivity concentration in sansai gradually decreased. However, most of the sansai collected still exceeds the safe limit for general food in Japan of 100 becquerel per kilogram. Especially, Koseabra shoots are more contaminated than other sansai. Koseabra shoots is called a queen of sansai, and taste of tempura is very tasty. If you have opportunity, please try to have it. In addition, there are large variations in concentration within the same kind of sansai. Based on this kind of situation, these are our research questions. We hope the answers will help reduce resident anxiety. In order to answer these questions, we have investigated. The announcement from our institute. Okay, I'll keep on my presentation. We have investigated the mechanism of radioactivity uptake from soil to sansai and mushrooms. We have also collected basic data such as consumption rate of sansai and mushrooms and radioactivity removal factor by cooking in order to estimate the possible radiation dose from eating them. In today's presentation, I will introduce our past efforts focusing on Koseabra shoots. First, to analyze the mechanism of radioactivity migration, we collected Koseabra shoots and soil samples, both organic layer and inorganic layer, from several sites in Fukushima with different radioactive contamination level. We analyze radioactivity as well as other elements, stable cesium, potassium, and other elements. Secondly, to estimate internal exposure through consumption of sansai and mushrooms, we developed a paper-based questionnaire and estimation. So questionnaire to estimate the amount of consumption. In addition, we also estimated the removal factors throughout cooking by calculating the difference in the radioactivity content in sansai before and after cooking with methods. Now I will share our tentative results. As you can see these graphs, we clarify that the concentration of radioactivity in Koseabra shoots was positively correlated with its accumulation in the organic layer rather than with the total radioactivity inventory in the inorganic layer. This suggests that organic layer possibly has a more important role in transferring radiocesium to the shoots near the coccyabral root system. So in order to clarify the contribution of organic layer more concretely, we examine the relationship between radiocesium activity concentration in coccyabral shoots and accumulation of exchangeable cesium-137, which was extracted by 1 mole of ammonium acetate solution in each soil layer. These graphs show the relationship in each soil layer, and as you can see, the concentration of radiocesium in coccyabral shoots had a significant positive correlation with exchangeable cesium-137 accumulation in the organic layer only. This suggests that radiocesium with higher bioavailability in the organic layer directly contribute to transfer of radiocesium to the shoots via the coccyabral root system. So based on these results, we conducted attempts to reduce radioactive contamination in coccyabral shoots. We applied 2 methods. One is additional fertilization of potassium chloride to control the root uptake of exchangeable radiocesium in soil. Another organic layer removal by installing fences and regularly removing accumulation of organic matter to prevent the role as a supplier of radiocesium. And for the results of these attempts, unfortunately, we could not confirm any immediate effect. This graph shows comparison of cesium-137 activity concentrations in coccyabral shoots in treated and controlled area 1 year after the attempt. We had really expected these blue or red colored squares showing the results by potassium chloride addition or organic layer removal would be plotted lower part than this regression line for the results in the control area, but that did not happen. We are now looking for the cause, and the translocation from stem or roots may be dominantly influential. Then as for removal factors by cooking, this graph shows the removal factor patterns for these procedures. As you can see, after being only soaked in water, not much radiocesium was removed. On the other hand, 1 minute of boiling and then being soaked in water could be remove more than half of the radiocesium in the sun side. In the future, we will develop a database with the consumption rate of sunlight and mushrooms and removal factors in several cooking procedures. So this is the last slide. Based on these results to date, we are going to develop this research project more. We are keeping to verify effectiveness of various measures such as delayed release, potassium fertilizer, decontamination, root cutting, and their combinations for not only immediate but also mid and long-term effect. We are also planning to apply this research framework to other sunlight and wild mushrooms. Of course, the estimation of additional exposure dose is extremely important and output for this study. So we are working on the assessment of internal and external exposure respectively. Finally, by organizing results, knowledge, and experiences from these approaches, we will provide information on countermeasures available to local residents and the risks rooted in their lives. That's all for my presentation. Thank you for your attention.